So, dear students, so we are starting with our next topic, that is next energy conversion device, that is the air compressor. So, this is the uh, energy conversion device in the unit of introduction of energy sources and its conversion for the subject systems in mechanical engineering. So, we'll see the first what is meant by air compressor. So, air compressor, the main function of air compressor is to compress the certain quantity of air or gas. So we can compress a quantity, certain quantity of air and gas from suction pressure. Generally, it is the atmospheric pressure of the air to a required delivery pressure. So, for example, if we compress, compressor is used to compress the atmospheric pressure, that is 1.0123 bar. To required pressure, it may be 5 bar, 10 bar. So this is the main function of air compressor. Now, in order to compress air or gas, the certain amount of energy is required. Hence, it is necessary that the air should compress with minimum expenditure of energy. So, minimum power requirement or minimum requirement of energy, the air should be compressed. So the compressor required a prime mover, which can be either electric motor or in some case it is the internal combustion engine, or it is also called as a IC engine, where by using this electric motor or IC engine we can compress the air. So the compressed air finds many applications because this air or compressor air is easy for transmission from one place to another place. So it has many applications. So some of the application of compressed air that are used in operations of pneumatic drill, then hammers. It is used in hoist, then control systems, then airbags that are used in automobiles, air brakes. Then we have sprays, spray painting, and in that, and sometimes it can be used in blast furnaces. So it will uh, burn the fuel in presence of this compressed air. Also, the compressed air is plays very important role in performance of IC engine. That is mixture of air and fuel mixture. It is burned in the IC engine, and also the gas turbine. It works on a principle of this uh, gas or compression principle. So compressor also finds its application in refrigeration and air conditioning. So all refrigeration system and air conditioning system has a compressor. A generally hermetically sealed type of compressor. It is used in a refrigeration system. So this is regarding some introduction of this air compressor. Now we will see the terminologies that are used in air compressor. So first terminology is single acting compressor. So what is meant by single acting compressor? Now in compressor there are two stroke are mainly required. One is suction stroke and second one is compression stroke and delivery stroke. So there are two strokes for the working of this air compressor that we will see in latter part of this video. So in single acting compressor, both suction as well as compression and delivery of the air, it takes place from only one side of the piston. It is called as single acting cylinder. So suction is takes place from one end, and when piston moves to another end, there will be a compression and delivery takes place. This is the first terminology, that is single acting compressor. Now we have another terminology that is called as double acting compressor. Now in double acting compressor, these two stroke, that is suction stroke and compression and delivery stroke of air, it takes place from both side of the piston. So when piston moves from left to right, suction will be there as well as compression will be there. When piston will flow from right to left, that is forward motion, and in backward motion, both suction as well as compression and delivery, both strokes takes place. So it is called as the double acting compressor, where suction and compression, it takes place from both side of the piston. Now we have the third terminology, that is the single stage compressor. So in single stage compressor, the compression of the air from suction pressure to delivery pressure, it takes place in one stage or in one cylinder only. It will be taken suction, the compression will be taken place from suction pressure to delivery pressure in only one stage or in only one cylinder. In multi-stage compressor, the compression of air from suction pressure to delivery pressure, that can be taken place in more than one cylinder or more than one stage. That type of compressor is called as multi-stage compressor. So first, air delivered by first compressor at a higher pressure of the first cylinder becomes the intake or suction for the second cylinder. And again, the higher pressure of second cylinder is becomes the intake for third cylinder, and this goes on so on. So this is in case of multi-cylinder, multi-stage compressor. Now there is another important terminology that is called as a ratio of compression, or it is also called as a compression ratio. It is generally denoted by CR, compression ratio. So this compression ratio, it is nothing but the ratio of the absolute delivery pressure to the absolute intake pressure. So output pressure, that is nothing but the pressure at delivery valve, and input pressure, that is the suction pressure. Generally it is the atmospheric pressure. So this is the compression ratio. Next important terminology, it is known as FAD, that is free air delivery or free air delivered. So actual capacity of compressor is the actual quantity of free air delivered. That is quantity of air delivered at intake condition, that is called as free air delivery. And the next concept is the clearance volume. So the space between top dead center of piston and cylinder head, it is called as clearance volume. So in piston and cylinder arrangement, so there is a piston and cylinder will be there, and between this piston and the head, the space is there, that volume is called as clearance volume. And there is another volume, it is called as a swept volume, VS. So this swept volume, it is nothing but the stroke of the piston. So it is from top dead center, that is TDC, to BDC. So that volume swept by a piston, it is known as swept volume. And clearance volume is the space between this top dead center and the cylinder head. So that space is known as clearance volume. And total volume is nothing but the swept volume plus clearance volume. So these are the some terminologies that are used in air compressor. Now we will see the different classification of this air compressor. So compressor are classified into as like pump. They are classified into positive displacement type of compressor and dynamic compressor. This dynamic compressor, they are again classified into centrifugal compressor and axial compressor, where the positive displacement type of compressor, air compressor, they are again classified into reciprocating type and rotary type. The reciprocating type of positive displacement compressor, it is again classified into single acting reciprocating compressor, double acting reciprocating compressor, and diaphragm reciprocating compressor. And this rotary compressor, they are classified into lobe rotary compressor, liquid reed type of rotary compression, screw rotary compressor, scroll rotary compressor, and vane rotary compressor. So these are the classification based on different criteria. So it may be positive displacement type of compressor or it is a dynamic type of compressor. Now we will see the working principle behind this compressor. So if you see in air compressor, these are the main parts of air compressor. So we have a cylinder, then this is the piston, this is the crank, and this is the connecting rod. So piston is move inside the cylinder. So if it is vertical cylinder, it will move up and down motion, up motion and upward motion and downward motion. Now we have a discharge valve, and from that the compressed air is delivered where the application will be there by using discharge pipe or deliver pipe. Then there is a suction pipe through which atmospheric air is sucked inside the cylinder, and this is the suction valve. So generally this type of valve, discharge valve or suction valve, it is the spring loaded valve. Then this piston, it will reciprocate inside this cylinder. So reciprocation motion means either it is upward and downward motion, or if it is horizontal cylinder, it is forward and backward motion, or it is also called as a to and fro motion of the piston. Then this is the connecting rod which connects uh, piston. One end of this connecting rod is connected to piston and another end is connected to crank. So when electric motor is connected to this crankshaft, when electric motor is rotate, this crank will gets rotating and this will oscillates this connecting rod, and because of oscillation of connecting rod, the piston inside this cylinder, it gets reciprocating. Reciprocating means upward motion or downward motion of the piston. So the diagram for a reciprocating type of air compressor is shown in this figure. So we have a crank that will rotating in this direction, that is in anti-clockwise direction. This is the connecting rod which connects crank with the piston. Then this is the piston that will move in upward direction or in downward direction. There are two types of valve. One is inlet valve. That valve is also called as uh, the suction valve. So from that inlet valve or suction valve, air inside the cylinder is supplied by using inlet valve, and the compressed air, it gets passing out from this valve. That valve is called as outlet valve, or it is also called as discharge valve. Now we'll see what is the working principle behind this reciprocating air compressor, as well as the components and function of each components of this reciprocating air compressor. So in this reciprocating compressor, the gas volume is decreases. The volume decreases. So the volume decreases, the pressure will be increases. So we know that pressure is directly proportional to volume. Inversely proportional to volume. So if volume increases, it will decrease the pressure, and if volume decreases, it will increase the pressure. So in the compressor, there is two stroke is there. So in first stroke, there is a suction stroke, and second one is the delivery stroke. So in downward motion of the piston, the vacuum is created, and from this suction pipe, air is passed inside the cylinder during the downward motion of the piston. So at this bottom end dead center, the whole air, atmospheric air, gets filled in this cylinder when piston moves from this top dead center to downward bottom dead center, that is in downward stroke. So that stroke is called as a suction stroke. In next, when piston will move in upward direction, So the area of cylinder gets decreased. So as the volume gets decreased, uh, the pressure inside this air goes on increasing. And as pressure goes on increasing, it achieve this required pressure, then the discharge valve gets open and the compressed air is passing through this discharge valve to the application. So there are mainly two stroke. One is suction stroke and another one is compression and delivery stroke. So the basic principle behind that, in the compressor, the volume of gas or air gets decreases and there will be increase in pressure because of the action of one or more reciprocating compressor which are moving in axially in one or more cylinder. So either in it will be acting in single stage reciprocating compressor, or it may be in multi-stage, where in single stage there is only one cylinder, in multi-stage we have more than one cylinder. So it may be a single acting or double acting single cylinders, or it may be a single cylinder engine reciprocating compressor or multi-cylinder reciprocating compressor, or it may be single stage or multi-stage compressor. Now if you see in reciprocating compressor, the basic components of reciprocating compressor are: first component is piston. So this component, it is called as a piston. Second one is the cylinder. So this component, it is a cylinder. So here this cylinder is there and this is the piston. Third part is connecting rod. So that will connect piston with this crank. So this part is called as a connecting rod. So the connecting rod, whose one end is connected to the piston and other end is connected to the crank. So the big end, it is connected to crank and small end is connected to piston. Again, this crank is connected to crankshaft and this crankshaft is again coupled to this electric motor or by IC engine, a shaft of IC engine. And when IC engine or electric motor gets rotates, it will rotate this crank. And this suction and compression, these two strokes will be happen. Another components are suction pipe, suction valve, again discharge pipe, discharge valve. So these are the components of this reciprocating compressor. So discharge valve is also called as outlet valve, and the suction valve, it is also called as a inlet valve. So the inlet and outlet valves are also provided with the cylinder head. So in this cylinder head, this is called as a head. So piston will move up to this point. So this volume, it is called as clearance volume. And from this to this end, this volume is called as a swept volume. So the inlet and outlet valve are also provided with cylinder head, which are operated by means of pressure difference. So if the atmospheric pressure will be there, it will open the suction valve, and if the pressure is above the atmospheric pressure, it will open the outlet valve or discharge valve. So because of pressure difference between these two valve, inlet valve and outlet valve, these two valves get operate. So in general, the piston reciprocate inside the cylinder, which is either air-cooled cylinders or a water-cooled cylinders are there. As like IC engine, it may be air-cooled engine or it may be a water-cooled engine. So this is the working principle and components of the reciprocating air compressor. Now we will see the working of this reciprocating air compressor. So here, this is the cylinder head. So these are the two valve, inlet valve and outlet valve. So air intake inside through this inlet pipe, and through suction or inlet valve, it will air go inside this cylinder. And when piston will move from this end is called as top dead center, this end is called as bottom dead center, and this length is called as a stroke length. So stroke is nothing but the piston moves from TDC to BDC and from BDC to TDC. So an ideal reciprocating compressor, it having some assumptions. So these assumptions are: there is no clearance volume in cylinder, but in actual compressor there is a clearance volume. So this clearance volume is required for this valves, suction valve as well as delivery valve. But it is an ideal reciprocating engine, so there is no clearance volume. Then working fluid is behaves like a perfect gas. So this is the second assumption. Third assumption: there is no frictional loss, but actual in compressor there is a frictional loss because there is a friction between piston and cylinders. Next, fourth assumption will be: there is no loss during the passing of fluid through the valves, but actually there is a losses will be takes place when fluid gets passing through these valves. Either it may be suction valve or it may be, but it is a diagram, or we can say it is the cycle for ideal reciprocating compressor. Now, if you see, there are four processes actually there, but actually main three processes are required. So first process is 0 to 1. This is the first process, 0 to 1. That is the 0 to 1 cycle. Then 1 to 2, it is second cycle. Then 2 to 3, we have third cycle. So at this 0 to 1 cycle, we have pressure P1. That is at point D, we have pressure P1. And between 2 to 3, we have pressure P2. So this P2 upon P1, it is nothing but a compression ratio. So it is outlet pressure P2 divided by inlet pressure P1. Now we will see all these processes, that is process 0 to 1, 1 to 2, and 2 to 3. So first we will see the first cycle or first process, that is 0 to 1. So this 0 to 1 process, it is isobaric suction process. Now what is meant by isobaric? Isobaric means the pressure during this process 0 to 1 is constant, and the volume is increased from this 0 to 1, we get the increase in volume. So constant pressure is there and volume gets increases. So this is an isobaric suction process during which piston moves from top dead center to bottom dead center. And in this condition, the suction valve is open during this process, and the gas, or we can say air, at constant pressure P1 is flows inside the cylinder. That is at atmospheric pressure mainly. If it is air compressor, the atmospheric air get filled inside this cylinder. This is called as first process. That is during this TDC to BDC movement, we get this cycle 0 to 1 process complete, where it will the air inside the cylinder, air inside the cylinder, it is filled through the suction. Now we have a second process, that is 1 to 2 process. So here this is a 1 to 2 process. So in this 1 to 2 process, it is a isentropic compression processes. Now this is a compression stroke will be takes place. So during this process, the piston will move from BDC, that is bottom dead center, to top dead center. So in this direction, the piston will move. So as piston will move from BDC to TDC, both suction as well as discharge valve, both valves are closed during this process, and the pressure inside the gas, it will increases from P1 to P2. So in this cases, the pressure goes on increasing. Why? because volume goes on decreasing. So as volume goes on decreasing, the pressure inside the cylinder goes on decreasing. Uh, Volume goes on decreasing, it will increase the pressure from P1 to P2. So various types of compression process in reciprocating compression is there, that we will show in PV and TS diagram in next slide. So there are three types of process. Now in this diagram we have isentropic compression process, where uh, the value of gamma, it is 1.4, that is the air. Now we have another type of compression process, it is called as polytropic. This process is 1 dash 2 dash 1 to 2 and 1 to 2 dash, that are in the next diagram. It is not for this diagram. So in this diagram there is isentropic compression process, that is 1 to 2. So in next diagram we have isentropic compression, then polytropic compression, and isothermal compressor. So in isentropic compression, where the pressure is decreases as well as pressure is increasing and volume gets decreases. In case of polytropic process is there, and in isothermal process temperature remains constant. So that we will see this all this process in next time. So if you see in second process, the compression stroke will be happen. So starting of compression stroke will be there. Okay, that is pressure is increased from 1 to 2. So pressure is increased from P1 to P2. Now we will see the third process, that is between 2 to 3. So between 2 to 3, the delivery of air will be there. So that is nothing but the in 2 to 3 process, it is an isobaric discharge process. So in isobaric, the pressure remains constant. So in this 2 to 3 process, the pressure remains constant and volume goes on decreasing. So volume from V2 to V3 is goes on decreasing. So during this process, suction valve remains closed and the discharge valve is open, and gas at constant pressure, that is at P2, is expelled from compressor as the piston will move towards TDC. So both, when piston is moved from BDC to TDC, this both process will be happening. So first process will be the compression between 1 to 2, and next process is 2 to 3, that is nothing but the delivery at constant pressure. Now there are two stroke. I have already shown these two stroke. One is suction stroke and another one is compression stroke. So if you see, this first diagram is of suction stroke and second diagram is of compression stroke. So in suction stroke, when piston moves in downward direction, now it is for vertical cylinder, the vacuum is created and air is sucked inside the suction valve to the cylinder. Now second stroke is compression and delivery stroke. So when piston will move in upward direction from BDC to TDC, the pressure of air is increased and delivery strokes opens and compressed air gets discharged from the discharge valve. So I have already shown that. So there are three types of process. One is isentropic, second one is isotropic, polytropic, and third one is isothermal process. So in isentropic, this process, that is one, we'll see. So isentropic process is denoted by this 1 to 2 dash. 1 to 2, it is polytropic process. 1 to 2 dash, this will be the isentropic process. 1 to 2, it is the polytropic process, and 1 to 2 double dash, it is the isothermal process. So these are the three processes. So if you see in all these three processes, in this isentropic process, the delivery will be start from this point to, that is 2 dash to 3. In polytropic, the delivery of the air will be starts from this 2 to 3, this small part. And in isothermal process, the LU will be between 2 double dash to 3 double dash. In TS diagram, you will see the isothermal process, that is in 1 to 2 dash, the temperature is constant. In other two process, temperature is does not constant. So these are the two stroke, that is one is suction and another one is compression. So this will be the suction stroke, this will be the compression and delivery stroke. So this is the working of reciprocating air compressor. Now we'll see the next type of compressor, that is centrifugal air compressor. Now as like pump, same components is there of centrifugal compressor. So we have impeller, then these are the blades, then there is a guide vanes, so that is called as a diffuser static blades. So air intake is there at this eye of impeller, the air intake will be there, and this air gets pressurized when the rotation of this impeller will be happen, and it will delivered from this delivery pipe. So all other components and working is same as that of pump. Only in case of pump, we have a liquid type of fuel, a liquid working fluid is there. In case of this compressor, we have either air or gas as a fuel. Fluid is there. So the essential part of centrifugal compressor is same as that of pump. It consists of a rotor with series of curved blades. So this is a rotor with series of curved blades. So this part is called as a impeller. Air is drawn through the opening near this hub part, or we can say a rotor part. The impeller is rotating at high rotational speed, and the static pressure of air gets increases from eye of impeller to the outlet. So it will increase the pressure of the air. So air which is leaving from impeller tube is passed through the diffuser, which provides around the impeller. So in pump it is called as a guide vanes, here it is called as a diffuser. So this diffuser converts the kinetic energy of air into pressure energy. So the centrifugal compressor, it is used for low pressure and high volume of air. Where we require high volume of air and we require low pressure between suction volume and delivery volume, we use this centrifugal type of compressor. If we require high pressure, then we have to use the reciprocating type of air compressor. So this is about the centrifugal air compressor. Now next will the different types of application of air compressor are there. So we'll see the air compressed air is used in operating the pneumatics tools like drills, hammers, etc. Then the compressed air, it is used in driving of compressed air engine. So based on this compressed air, we have engines where that will work on a compressed air. Next, we have spray painting, that is based on the compressed air. Then a refrigeration and air conditioning system, it is works on a air compressor. In refrigerator, we use hermetically sealed compressor is there. That is a black like box will be there. So that is the compressor, air compressor will be. Again, this air compressor or compressed air is used in gas turbine power plant, where we convert the energy of the gas into a electricity. So that type of power plant is called as a gas turbine power plant. Next, compressed air is again used in supercharging of IC engines or internal combustion engines. Then there is a one pneumatic conveyor is there, which is based on compressed air, where that conveying materials from one place to another place. over a considerable distance, that is up to 10 meter or 20 meters. Then this air compressor, it is also, or compressed air is also used in mining machineries, then in blast furnace. So these are the different applications of air compressor, or we can say compressed air, that is used in different applications. So this is all about uh, the energy conversion device, that is the compressor, where we can convert the electrical energy, that air compressor converts the electrical energy into the pressure energy, that is nothing but the pressure of the air, compressed air is that. So this is all about uh, air compressor. So thank you for watching my videos, and also uh, subscribe my channel so that other videos also visible to us. So thank you very much for watching this video. Thank you.